Yeah, we're looking at the Bernoulli differential equation. And Bernoulli differential equation is of this form. It is of the form, the y, the x plus p of x, p of x y equal to q of x y n. Okay, so that's the form of Bernoulli equation. Okay, this is the first order differential equation. Okay, then we must know that n in this aspect is not equal to 0 or 1. If n is equal to 0 or 1, it becomes what? Linear differential equation. Okay, so for Bernoulli, n is outside 0 or 1. So that's that on this equation. So the next thing we want to look into now is how to solve it, how to solve uh, Bernoulli equation, how to solve Bernoulli differential equation. Okay, so let's look at that. Um, the first thing we must do is to step one is to divide through by the attachment of your qx by what? Y what? Y n. That's step one. Okay? So if you do that, you now have, you know, when you divide the y, the x over yn, that will become yn minus 1 dy dx. That's one. Also here, you're slashing that p of x, y. This is having power 1, okay? And you're dividing by what? Yn. So this will give you p of x, y. This is 1 here, so 1 minus n. Okay, so you now have y minus this dy dx plus p of x 1 minus n, and here is equal to this. Good. This will leave this place the moment you divide through by that attachment to q of x. So this is all you have now. Then step two. Step two is to do substitution by using v equal to everything here, y into this. That's step two. Use a substitution. Call this expression. Okay. Whatever you have here with your p of x, the attachment to p of x, give it a letter v. Okay. Then you now differentiate this. Then the next thing is to differentiate implicitly. Differentiates implicitly with respect to x. So this will now become the v dx. Okay, and this will give you this one will come to the front, 1 minus n. Then you have y minus 1, and that will give you minus n, then dy dx. Okay, this is implicit. What we mean by this is this: if your v is this and you want to differentiate, you have this. Okay, so y is a function of itself, and at the same time, it's a function of x. So it's going to be the v dx. Then this will be d dy of this function, d dy of this function, and then times. That is y is a function of itself, and again a function of what? Of x. So that's how to do implicit differentiation, and that's what we have done here. Okay, That's what we have done here. Then the next thing to do is to make this a subject of the equation because we have it here, okay? And want to change the variables here, okay? You see it now. Make this one the subject, make that one the subject, and if you do that, if you do that, you make that one the subject, then you have, now you are dividing all through by 1 minus n, and that's 1 over 1 minus n dv dx, dx. And that's equal to what? Is equal to this, the y, dx. So that's that. Then the next thing to do now, you can call this, whatever you want to call it, maybe 1, star 1. This one here, we need it. We can call this one star. So put this one into this place and substitute for what? For v. So you now have already we know an expression for this. We have that here in that equation star 1, and that will be equal to 1 over 1 minus n dv dx, okay, then plus p of x equal to this expression. We have given it a letter b, which is b, okay, equal to q of x, okay. So by the time you look at it now, you now see that this is what? This is linear. This is linear in v. And we have discussed about linear equation, and you can solve it linearly, okay, in a linear differential equation. You can solve it in that way. So that's just that on how to solve Bernoulli differential equation. Without wasting time, let's look for questions. Let's go to questions. Thing we do, don't forget the form of Bernoulli equation, which is of the form dy dx of the p of x y equal to what? P of x yn. Okay, so with that now we can correlate the question to this form. That means we need to remove this one from here so I can follow the standard rules. Okay, divide the questions by the what? By the x. Divide through by x. So with that now you divide through by what? By x. Then we have y prime is the y dx. I want to change the y dx. Then this will be equal to the main one here, to plus x, y, and then equal to 6x. And then this radical, you can remove that. You can remove the square root, and that will equal to y half, y to the power half. So that's what we have now. Then the next thing to do now is to divide through by this. Okay, then you now have y minus half here, the y dx plus x is there. Then what do you have here? That's y power 1 to 1 minus half. Okay, then you have what? 6x here. Okay, then the next thing to do now, you now have y minus half, the y dx, then plus x, y. 1 minus half will give you half, okay, equal to 6x. Okay, so the next thing we do now is to do a substitutions for the attachment to the p of x, which is equal to this one, b equal to this. Then differentiate implicitly, then you have the v dx, equal to, this will be equal to half, okay, half, then y, differentiation, how to differentiate, half minus 1, and that minus half. If you're having problem with differentiation, there is exclusive videos, okay, that take care of everything you need to know about differentiation. So please watch those videos. So we have this, then the y, the x, okay, and you can see now it's now taking this one now. You can see we have it here, okay. So what we do here now, there's a half here. We need to cancel that half by multiplying 2 by 2. So we have 2, the b, the x equal to what? Y minus half the y dx. Can you call this one maybe star 1? Whatever you want to call it. So this one also, maybe star 1, this one star 2. So put this one into this place and also substitute this one also into this place. So equation star now become this one. We have an expression for that, which is what? 2. You know, you can see this one now as a subject. It's equal to this. So anywhere you see this, you just plug in this one there. Okay. So and that will be equal to 2 dv dx. Okay. Then plus x. This y2 power half. It has a letter which is v. We've done the substitution for that, which is v, and that's equal to 6x. Okay. Then the next thing we can do now, we can remove this 2 from here by dividing through the equation by 2. And we have dv dx plus x over 2 v equal to what? 3x. So this is our equation now. And this equation is linear in what? In v. This is what? This is linear. This is linear in what? In v. Okay, so then we can now use the method of linear differentiation to solve that. Okay, whereby if you correlate that to your linear equation, the linear equation is of this form, y dx plus p of x y equal to q of x. So if correspond that to this now, you see that your p of x is half x over 2. Okay, and your q of x is 3x from that equation star, the star 1, they call it star 1, the equation. Okay, so we can get the integral factor now, the integrating factor, which has the formula of this p of x dx, and that's equal to integral, and we can take that will be x over 2 dx. Yep, and then we can take the 2 outside, which will be equal to e 1 over 2 integral of x dx, which will be equal to e to 1 over 2 integral of x will be x2 over 2. Okay, so and this will give us what? E x2 over 4. That's the integral factor. Then after that, after you've gotten your integral factor, then you can write the words. You can get the general solution. Okay, and that will be equal to, since it's linear in v now, it will just be v equal to, okay, 1 over integral factor. 1 over integral factor. Our integral factor is what? Is e x2 over 4, e to power x2 over 4. Then open your brackets, your integral factor mu, this one, x2 over 4 times your q of x, 3x. Okay, then dx, then plus c. Okay, I've explained this on linear differential equation. If you missed the video, please quickly go there now and watch the video on linear differential equation. Okay, so this is what we have now. The bone of contention now is how to integrate now. Okay, look at what you have here. Okay, you can use change your variable, and by calling the power of the exponent, power of the e, call it let's give it a letter u. Let's call this one a u. So your du will be equal to 2x over 4, which is equal to x over 2 dx. X over 2 dx. Okay, and what we are trying to do, we are trying to ensure that this variable here also cancel and the 3 can go outside and can differentiate. So that's that. Can we make the x the subject Let's make the x the subject. So we have the u is equal to x over 2 dx. So cross multiply, then we have 2 du over x equal to dx. Okay, so we can go back to our general solution. V equal to 1 over e x2 over 4. Okay, then integral eu, okay, dot 3x. Then we have expression for dx, and my dx is what? 2 over x, 2 over x du. So this one will cancel out. That variable will cancel out. Then we have what? 6 will be outside. 3 times 2, that will be 6. Okay, and that will give us plus c here. And that will give me 1 over e x2 over 4. And this will give us the integral of this. You're having now 6 could be outside, and that will be eu. And integral of e to exponential integration is the same thing. That will be eu. Don't forget your 6 that, then plus what? Plus c. So what we just need to do is just to plug back the u. So the final answer will now become 1 over x2 over 4 into bracket 6e. The u is what? x2 over 4. Okay, x2 over 4, then plus c. And that finished that. Then the next thing to do now, you can open your brackets, and don't forget that this one is the same thing as a negative. This and this will cancel out. You have 6 plus what? Plus c e minus x2 over 4. If you remove 1 over, so you have this as your answer. That's your v. Then you can substitute back for your v. Your v is what? Check the question. What's our v in that question? Our v is I think we use a v equal to y2 half. Yeah, that's our v. Okay, so return that back, and that will equal to y to power half. So that's our answer. The only thing we need to do is just to square both sides, so that the half here will go square both sides. Then you have y equal to 6 plus this minus x2 over 4 square. Okay, so that's just that on this. And if you don't want to use minus here, you can just say c over this. So that's that on this question. Let's start on that question. Let's do the next video. We're still on Bernoulli differential equation.